All right, so today we're going to start going over something called the standard normal distribution. So whenever we talk about the standard normal distribution, pretty much we're talking about the z-value. So I'm going to go ahead and share my screen so that way you can see the notes. All right, and also today we are going to be doing a lot of stuff in class Cal. So you might want to have that handy for that we can kind of follow along, because like in order to get that information, it's not that hard, but you do want to kind of practice for that way. Well, you can get some practice and that way you know you're doing it correct. All right. Give me a minute. Let me close out some stuff. Cool. All right. So today we're going to learn about the standard normal distribution. So whenever we talk about a standard normal distribution, what that means that the mean is equal to 0 and the standard deviation is equal to 1. So whenever we know is a standard normal distribution, mean is automatically equal to 0 and your standard deviation is automatically equal to 1. So usually the way that you know you have the standard normal distribution, if you have the z-value. So automatically, if you have the z-value, you should kind of automatically know that your mean and your standard deviation is equal to 0. So if I tell you z is equal to 5, you should automatically know, since we have the z-value, the mean is automatically equal to 0 and the standard deviation automatically is equal to 1. So what if we don't have the z-value? Well, if we don't have the z-value, you could easily find the z-value. And the formula to find the z-value is right over here. So if we want to find the z-value, all we have to do is x, which is the value that we want to convert into the z-value, and you subtract that by the mean of that population, and then you divide it by the standard deviation of that population. And this is called standardizing the score. So anytime we don't have a z-value and we want to convert it into a z-value, well, this is how we'll convert it into a z-value. You take x, which is what we want to convert to a z-value, you subtract it by the mean, and you divide it by the standard deviation of the population. Everybody good for that so far? All right. So if we say we have a standard normal distribution, what that means, our data set is symmetrical. So if we have pretty much something that look like this, you just kind of know that the area is equal to 1. So if I were to find this entire area, it will add up to 1. Also, you kind of know if I were to cut this in half, since you cut it in half, and since the whole area is equal to 1, pretty much 50% or 0.5 will be on the left-hand side, and 0.5 will be on the right-hand side. So you kind of know if you cut the area in half, half of it should be on the left side, half of it should be on the right-hand side. All right. So if you look right there in the question, it says, what is the standard normal distribution? So pretty much it means when you have the d value and mean is automatically equal to 0, standard deviation is equal to 1. All right. So one definition that you should definitely know is the standard normal distribution. If you have a standard normal distribution, that means you have the z value, and that means the mean and the standard deviation 0 and 1 respectively. Any question in regard to that so far? All right, so let's move on down. All right, so for this one, it says find the proportion of observation from the standard normal distribution that are less than 0.54. So I'm gonna write it 2 different ways. So one way I could write it, I could tell you this is a standard normal distribution. So when I say less than 0.54, I'm telling you that z is less than 0.54. Or other way I could put this, I could put this that the probability of z is less than 0.54. And then you're gonna have to find that probability. So you kind of want to be familiar with both of these cases. All right. Everybody good so far with both of those notation? Yes. All right. Well, thanks, Aaron. So up next, what we're gonna go ahead and do, we're gonna go ahead and do a drawing, because this drawing should help you out to kind of see if you're doing it correct or if you're, well, doing it incorrect. All right, so just know for the standard normal distribution, the middle will always be 0. So if I look at 0.54, where would it go in respect to 0? Would it go to the left of 0 or would it go to the right of 0?
The right.
Yeah, perfect. There you go, 0.54. So now if you look at this symbol means less than. But kind of think about it as an arrow. So if you look at it, which side is it pointing at? Is it pointing to the left side or is it pointing to the right side?
Pointing to the right.
Let's try that again.
My bad, it's pointing to the left.
Yeah, there you go. So if you look at it, it's pointing to the left. So it's telling you want to shade the left-hand side. All right, so you want to shade the left-hand side. So before we actually go, because in a little bit we're going to go to class calc to find this probability, we have to find 4 things. So the 4th thing that we want to find is what is our mean of the population? What is our sigma of the population? What is our lower bound? And what's our upper bound? All right, so for this one, the mean and the standard deviation, since we have the z value and since we have a standard normal distribution, in this case scenario, mean will be 0, standard deviation will be 1. This will always be the case when we have a standard normal distribution or if we have the z value. If you have one of those two, automatically your mean should be 0, your standard deviation should be 1. All right. So this is where it kind of get a little bit tricky. So what we're gonna do, we're gonna find the lower bound and we're gonna find the upper bound. So when we're finding the lower bound and the upper bound, what we're doing, we're finding the lower bound and the upper bound of the shaded area. So what we wanna do, we wanna see what the lowest value that gets shaded and what the highest value that gets shaded. So let's do the easy one. So let's do the upper bound. What's the highest number that will get shaded before it get cut off?
0.53.
Yeah, perfect. So if you look at it, the highest value is 0.54. So that's gonna be my upper bound. So instead of putting upper bound, we'll put UB just to make it a little bit shorter. So that's my upper bound because that's the highest point that gets shaded. What about for my lower bound? What's the lowest point that gets shaded? Or is there a lowest point, or does it keep on going and going?
Keeps on going?
Yeah, so it keep on going. So one thing you have to know, if it keep on going to the left-hand side, that means going to negative infinity. If you keep on going to the right-hand side, we say it's going to positive infinity. So since we keep on going and going on the left side, we're gonna say the lower bound is negative infinity. So right here we put negative infinity. Right here we put positive 0.54. All right. Everybody so far go with the lower bound, the upper bound? All right. So now we're gonna go ahead and we're gonna go ahead and transition over to class calc. So if you have it open, good, or if you have the app open, perfect. All right, let me minimize that. So the first thing what you wanna go ahead and do, you're gonna go to the stats button. Then what you're gonna go to distribution. So if you look at it right here, the binomial distribution, that's what we did yesterday. For today, we're gonna be focusing on a normal distribution. So you wanna click normal distribution. All right. So let me do that again in case you got lost. So you go over to stats, you click distribution, and you click normal distribution. So if you look right here in the question mark, it kind of helps you out. So it asks you what's the mean and what's the standard deviation. So the first thing you want to put the mean, which is 0. The second one you want to put is the standard deviation, which is 1. And if you look right here, well, let me minimize this. It gave me the drawing for my standard normal distribution. Let me move this up. All right, so that's my standard normal distribution. So now what I want to do, I want to tell it what's my lower bound, what's my upper bound is. So to tell it the lower bound, the upper bound, what you want to do, you want to click right here where it says CDF. All right, so if you look right now, it already has it from negative infinity to positive infinity. So from negative infinity to positive infinity, it's telling me it's 1 or 100%. But the thing is, my lower bound, I want it to be negative infinity. But for my upper bound wanted to be 0.54. And if you look right here, it gives you the drawing of it. So you can always double check your drawing and the drawing that ClassCalc give you to make sure that you're doing it correct. Because if the drawing that ClassCalc is giving you is different from the drawing that you did, then you know something is wrong because ClassCalc is not giving you exactly what you wanted. So if you look right here, we get 0.7054, and that's it. There you go, 0.7054. So the probability that we get something less than 0.54 is 0.7054 or 70%. Any question in regard to that so far?
How did you get the negative infinity symbol?
The negative infinity symbol, it was already there for me. But let me see. There should be a button. Here, let me check my phone. Or that way, if you're using your phone, I can tell you exactly where it is. Cool. All right. So if you look right here, you see how there's like a division sign right here. So what you want to do, you press negative, and then what you want to do, hold the division sign, and it will pop up the infinity. So that's how you get the negative infinity.
Thank you.
All right, everybody good on this? All right, so what I'm gonna go ahead and do, I'm gonna go ahead and transfer back, and we're gonna do part B. All right. So if you look at part B, it says greater than negative 1.12. So if I was writing that, it would say probably that Z is greater than negative 1.12. So let's go ahead and draw this out. So remember, you put 0 in the bottom or in the middle. So where does negative 1.12 fall in respect to 0? Does it fall to the left side or does it fall to the right side?
So
Left.
Yeah, good. So left. So we'll put it somewhere over here. So negative 1.12. So if you look at it, it says greater than, and if you look at this, it's pointing to the right. So say pointing to the right. So since it's saying greater than, and since it's pointing to the right, what we want to do, we want to shade the right-hand side. All right, so now let's do this again. So we're gonna have to find our mean. We're gonna have to find our standard deviation. We're gonna have to find the lower bound, and we're gonna have to find the upper bound. So the mean of the standard deviation is automatically gonna be 0 and 1, so you don't have to worry about that. So let's do the lower bound. So for the lower bound, what's the lowest value that I shaded in yellow?
negative 1.12.
There you go. So this is my lower bound. So if you kind of look at it, that's the lowest the shaded area go. So now what we have to do, we have to find the upper bound. So the upper bound, the highest possible value that gets shaded. So that's over here. But if you look at it, there's no definite like cutoff. So since there's no definite cutoff, what you want to just do, you just want to say keep going and going. Well, it keep going all the way to infinity. Everybody good with my lower bound, my upper bound?
Yes, sir.
All right, perfect. So let's go back to class count and let's get our answer. So if you wanted to, what you could do, you could just reuse this. So you can say, okay, my lower bound is now negative 1.12. And then you can say my upper bound, well, my upper bound is infinity. So you just hold the division sign and you get your infinity symbol. So always double check your drawing. So if you look at this drawing and if you look at the drawing that we drew, they pretty much look identical. So if you look at the probability, it says 0.8686. So the answer for part B will be 0.8686. Everybody good with part B?
Mm-hmm.
So let's do part C. So if you look at part C, it says greater than 3.89. So greater than 3.89, if I were to draw this, well, if I were to write this, it would be probably that Z is greater than 3.89. So let's go ahead and draw this. So if you look at it, here goes 0. So if you look at it, you have 3.89. So that's telling me we're like almost 4 standard deviation away from the mean, which is 0. So 3.89 should be somewhere over here. All right, so what we're gonna have to go ahead and do, we're gonna have to go do the mean, which is 0, standard deviation, which is 1. We're gonna do the lower bound, and we're also gonna do the upper bound. So for this one, what would be my lower bound? What's the lowest value that I shaded in pink?
3.89.
Yeah, there we go. 3.89. So that's the lowest value. So that's my lower bound. So then if you look at my upper bound, the upper bound, if you look at it, there's no real cutoff number here. So if you look at it, where you say this goes all the way back to infinity. Everybody get a lower bound 3.89 and my upper bound is infinity.
Mm-hmm.
All right. So up next, if you kind of look at it, 3.89, we didn't shade that much. So you shouldn't really expect that big of a probability. Like you should probably expect a probability like less than 5% because 3.89 is pretty out there. So let's go ahead and just kind of confirm that by doing class cal. So here, we'll do it all over again. So once again, we'll go stats, we'll go to distribution, we'll go to normal distribution, we'll put mean as 0, standard deviation is 1. We close the parenthesis and you do CDF. So for CDF, we do lower bound is 3.89. And we'll say upper bound is infinity. So you just hold the division sign. And if you look at that, we get 0.00005. The point, how many zeros are there? 1, 2, 3, 4, 4. 1, 2, 3, 4. All right, so we'll put 0.00005. And also, if you look over here in class cal, you can kind of see like it didn't cover that much of a probability. And that's it for C. Any question in regard to C? All right, so let's do D. All right, so if you look at part D said between 0.49 and 1.82. So whenever it says between, you want to write it like this: 0.49 is less than Z, which is less than 1.82. So that's how you say in between using the inequality. You put the two numbers, and then you put less than and less than. All right, so if I go to draw this out, so you put 0 in the middle, you put 0.49, and then you do 1.82. So if you look at it, since it has to be between 0.49 and 1.82, that means you shade between them. The double between mean, the mean is in the middle. So whenever it says between two number or two Z value, essentially you shade the middle portion. So once again, we're gonna say, what's our mean, which is 0? What's our standard deviation, which is 1? what's our lower bound, and what's our upper bound. So if you look at my lower bound, we have a cutoff. It get cut off at 0.49. But if you now look at my upper bound, we also have a cutoff for the upper bound. So that's 1.82. So kind of notice the difference between A through C. A through C, essentially, for one of the bound, there were no cutoff. But if you look at part D, since we want it to be between these two Z values, we actually have a cutoff for the lower bound, and we also have a cutoff for the upper bound. So we want it to be between 0.49 all the way to 1.82. So up next, I'm going to go ahead and go back to class cal, and I'm going to change my lower bound and upper bound. So if you look for my lower bound, we do 0.49. For my upper bound, we get 1.82. Here, let me take away this infinity. So you get 1.82. So if you look at the drawing, it has 0.49 all the way to 1.82. So if you look at the value it gave us 0.27707. And that's your final answer for D. Any question in regard to D? All right, so let's do E. All right, so last year we're gonna do E. So E is within 1.5 standard deviation of the mean. So within, it's telling us from the mean, it has to be within that value. So mean it can't go higher than that, and it can't get lower than that. So this is the other way of saying in between, but they're saying in between 1.5, we could also write it as this. So since we want to be within 1.5 standard deviation of the mean, that means from the mean, which is 0, we're going to add 1.5, and we're also going to subtract 1.5. Because if I go to the left-hand side, you have to subtract that 1.5 standard deviation. But if I'm going to the right-hand side, you have to add that 1.5 standard deviation. So for this one, the way we'll draw it, so we'll have negative 1.5 here, and we'll also have positive 1.5, and you shade these values in between. All right, so that's within 1.5 standard deviation. So you go 1.5 standard deviation to the left, which is negative, and then you go 1.5 standard deviation to the right, which is positive. So now we're gonna go ahead and we're gonna go ahead and do mu, sigma, and lower bound. And upper bound. So remember, the mu and sigma is automatically 0 and 1. And the lower bound, if you look at it, is over here, which is negative 1.5. And if you look right here for the upper bound, is positive 1.5. So when we go to class count, that's where we're going to enter. For the lower bound, we're going to enter negative 1.5. And for the upper bound, we're going to enter 1.5. So let's go to class count. All right, so for lower bound, we'll do negative 1.5. And then for the upper bound, we're going to do positive 1.5. All right, so if you look at, if I go 1.5 standard deviation to the left, 1.5 standard deviation to the right, in between those two values, you should have approximately 0.8664. And that's it for E. Any question for E? All right, so let's go back to my notes. All right. So to kind of recap what we're doing right now, pretty much right now, we're getting a Z value and we're finding the probability for that Z value. So this is important because right now we're gonna switch it around. So right now we're gonna start off with the percent, but we're gonna now convert it into a Z value. So you do kind of want to tell the difference between when do I want to convert a Z value to a percent, or when do I want to do a percent to a Z value. So in the last 5 problems that we did, we started off with a Z value and we ended up with the probability. Okay, if you look right here, we first started off with the Z value, but we ended with a probability. So that's going to change for the next problem. So for this one, it said a distribution of test score is approximately normal and Joe scored in the 85th percentile. How many standard deviation above the mean did he score? All right, so if you look at this one, we're stating that we're a certain percentage above the mean. And what we want to do, we want to find how many standard deviation above the mean did we score. So when it says how many standard deviation above the mean did they score, essentially this is Z. Because Z is telling us how many standard deviation above the mean we're at, or it also telling us how many standard deviation below the mean we're at. So let's go ahead and find this. So one thing you have to know about percentile is always the bottom percentile. So if I want 85%, that means this is 85%. So if you look at right here, that's the bottom 85%. So we have the bottom 85%. So what we want to do, we want to find what is the Z value that pretty much break up the bottom 85% with the top 15%. So that's what we're going to find right now, because essentially we have the bottom 85% and we have the top 15%. And we want to find out what is the Z value that pretty much separate the two values from each other. Everybody kind of go with the idea so far? All right. So if you look at the Z value, since the Z value is to the right of 0, so since the Z value is to the right of 0, you should expect the Z value to be positive. Because pretty much you think about it, this is like a number line. 0 is in the middle. So if we put the Z value to the right, that means we should expect a positive Z value. If we put the Z value to the left of 0, that means we should expect a negative Z value. All right. So one thing before we go to class calc. So for class calc, it's gonna ask you for the area to the left. But it's not actually gonna ask you area to the left, and you're gonna ask you enter the value. But you should kind of know when class calc is asking you to put in that value, it always wants the area to the left. So if you look at this little line that I did right here, what's the percentage to the area to the left?
85.
Yeah, 85. So in class calc, you have to make sure that you say 85. If you put 0.15, it's gonna give you a different answer. So you just kind of know, always give it the area to the left. All right, so let's go ahead and let's go to class calc, for that way I can show you how to enter this. All right. So for class calc, you're actually gonna do this in 2 steps. So just pay attention. So the first step you want to do, you want to go to stats, you're going to go to distribution, and you're going to do a normal distribution. So for the normal distribution, you're going to say 0 and you're going to put 1. So remember, the mean and the standard deviation, so 0 and 1. So once you put normal distribution, mean of 0, standard deviation of 1, next step you want to do, you want to go to stats. You're going to go to distribution. But what you want to do, if you look right here, let me get the annotation. If you look right here, you see how it says inverse CDF? Now you want to select inverse CDF. And for inverse CDF, all it's asking for, what is the probability to the left? So if you remember, we said the probability to the left was 0.85. So you're going to just enter 0.85. And there you have it. So now it gave me the Z value, and it's telling me Z value is 1.036. So we'll say is 1.036. And that's how you get the Z value. Any question on how we got that Z value? All right, no question. So let's go back to my notes. All right, so if you look right over here, I put the answer right here. So it says Z is equal to 1.036. I also put how do you enter it into class cal? In case you forget, you can just look right here, and that way, hopefully you can figure out how to enter that into class cal. All right. Any question in regard to that first problem? All right, so let's do the second problem. So for the second problem, it says in a normal distribution, Q1 is how many standard deviation below the mean. So for Q1, if you remember, this is a quartile. For this quartile, what percentage was this quartile?
Was it 85?
Which one was that again, Caesar?
Was it 85 for the recent problem?
No. Well, this is a new problem. Well, kind of think about it. If it's quartile, so it's essentially a quarter. So if it's a quarter, like what percentage would that be?
25.
25. There you go. So this quartile is the bottom 25%. So we put 0, and we'll put it right here because this is the bottom 25%. So what we're doing, we're looking for this Z value over here. So if we're looking for that Z value, pretty much one thing you should already know, since it's to the left of 0, we should be expecting a negative. All right. So if to the left of that Z value is the bottom 25%, to the right of it, how much percent will be to the right of it?
75.
Yeah, there you go. So I'm gonna go into class cal, and we're gonna enter this. So we're gonna say normal distribution of 0, 1, and then we're gonna say inverse CDF. And for this one, what should I say is the percentage for that CDF? What should I put in the parentheses?
0.75.
Well, let's check that again. Because remember, it
Maybe 0.25?
the left.
Oh yeah, my bad.
Yeah, that's fine. 0.25. So up next, I'm going to go to class calc, and I'm going to go ahead and enter this. So let's go to class calc.
So we always just enter the number that goes to the left?
Correct. You always enter the number that goes to the left.
Okay.
So we go to stats, we go to distribution, we'll go to normal distribution, we'll put 0, comma, 1. Then what you want to do, go to stats, go to distribution, go to inverse CDF, and do 0.25. Wait. And if you look at it, gave us our answer. So it gave us an answer that Z is equal to negative 0.674. And that's it for the second problem. Any question in regard to that second problem?
No.
Okay. Good. All right, so for this one says, how do you find a z-score or a distribution value if you are given the area? So remember, for this one, you first go and put in normal distribution. You put 0, comma 1, then do inverse CDF. And for the probability, you just always remember the probability to the left, probability of the left side. So it shouldn't be that hard. Like, as long as you keep on practicing and practicing, like it'll become a little bit easier. But like in the beginning, it'll be kind of hard just to kind of remember the step. But after a while, once you've done enough of these problems, like it should be easier to do. But that's your process of how to get a percent and convert it into a Z value. Boom. And if we want to take a percentage, we'll just do that for later. All right. So everybody good for a standard normal distribution? Okay. So now we're going to do, instead of doing a standard normal distribution, where a standard normal distribution is mean of 0, standard deviation of 1, we're going to do a normal distribution. So a normal distribution means that the mean and the standard deviation are not going to be 0 and 1. It's going to be something different. So I'm going to show you 2 ways how to do this, and it's totally up to you how you want to do it. So whichever way you find easier. So for this one says serving speed in the 2008 Wimbledon tennis tournament, Rafael Nadal averaged 115 miles per hour on his first serve. Assume the distribution of his first serve speed is normal with a mean of 115 and a standard deviation of 6 miles per hour. So if you notice for this one, they're giving us a mean and they're giving us a standard deviation. So they're telling us mean is equal to 115. They're also telling us standard deviation is equal to 6 just by the wording of the problem. Because they say the mean is 115, standard deviation is 6 miles per hour. All right. Everybody good on mean is 115 or standard deviation is 6?
Yeah.
All right, perfect. So for part A, it says about what proportion of his first serve would you expect to be slower than 103 miles per hour? So let's go ahead and draw this up. So here's 115. If you look at it, we have 103 because that's what we're trying to find. And they use the word slower. So if they use the word slower, which side of the 103 do you think we should say? The left side or the right side?
Left?
Yeah, there you go. Because anything slower than 103 will be on the left side because since this is going from lowest to highest, if it's slower than 103, that means we want like 100 or 99 or 80. So we shade the left side. Great job. All right. Everybody good with that so far?
Yeah.
Okay. So the first method that we're going to use is going to be the method where we convert this, we convert this and we convert it into a standard normal distribution. So instead of using 103, what we're going to do, we're going to convert 103 into a z value. So the formula for z is equal to x minus the mean divided by standard deviation. So in this case, since we're trying to find the probability of 103, my x will be 103. So I do 103 minus 115, and you divide this by standard deviation, which is 6. All right, so let me stop there for a minute. Any questions so far? I got the 103 minus 115 divided by 6. Okay, so I'm gonna go ahead and work that out. So I'm gonna do 103 minus 115. You get negative 12. If you do negative 12 divided by 6, you get negative 2. So you get z is equal to negative 2. So we'll put negative 2 over here. All right. Everybody good? Where'd the negative 2 come from?
Yeah.
All right. So remember, once you have the z value, what's my mean?
115.
Well, what's the mean of the z value? Because once we find the mean, once we find the z value, the mean of the standard deviation changes, and it changes back to 0 and 1. So anytime you find the z value, just know once you find the z value, that means automatically my mean automatically becomes 0, and my standard deviation will become 1. So once you have that z value, it now is a standard normal distribution. All right. Everybody go for this standard normal distribution?
Yeah.
All right. So let's go ahead and draw this out. So right here you put 0. Right here, since I found my z value to be negative 2, we put negative 2. We still want it to be slower, so you still shade the same side. So for this one, since we shaded the left-hand side, you still shade the left-hand side because you still want it to be slower than that. So let's do the mean. Let's do standard deviation. Let's do the lower bound, and let's do the upper bound. So for this one, what's my mean if I found my z score to be negative 2? Well, the mean should be 0. My standard deviation should be 1. For this one, what will be my lower bound of this drawing over here?
Negative infinity?
There you go, perfect. Negative infinity. All right. What will be my upper bound? What's the highest
Negative 2.
value?
Negative 2.
Yeah, negative 2. All right, so let's go to class count. So let's go to class count and let's do this. So remember, for this one, we have a z value and we're going to change it into a probability. So for this one, we do distribution, we do normal distribution, we say 0, 1, and you just want to put CDF. So in the CDF, what you want to do, you want to put the lower bound, which is negative infinity. And then you want to put the upper bound, where the upper bound is negative 2. And if you look at that answer, we get the probability that z is less than negative 2 is equal to 0.0228. And we're all done with that problem. Any question with that problem? All right, so let's go. So that's one way that you could do it. So that's the way where you convert into the z-value. And once you convert to the z-value, you use mean of 0 and standard deviation of 1. All right. But let's just say we don't want to do all of that work. We don't want to convert into the z-value. We just want to pretty much leave the mean and the standard deviation as is. So there's another way we could do this. And you might want to do it this way. But it kind of is up to you. So say if I just want to leave the mean as 115 and the standard deviation as 6, you could actually do that. So we could say the mean is 115 and we could say standard deviation is 6. So if you look at this problem, so now we're going to be looking at this graph over here. What will be the lower bound of that graph that I just pointed at?
Negative infinity?
Yeah, negative infinity. What's the upper bound of that graph that I just pointed at?
3.
Yeah, 103. So what I could actually do, I could just pretty much find the probability using this information. So instead of converting to a z-value, we could leave it as a normal distribution and still be able to find it. And I'll do a new one for that way you can see it'll still give me the same answer. So you go to distribution, you go to normal distribution. So right here, you want to change it to 115 and you change it to standard deviation of 6. Now let's go ahead and look at this one. All right, so if you look at, here's my drawing. So then you want to go CDF. Well, my lower bound is still negative infinity, so I can just leave it as negative infinity, but my upper bound is 103. So if you look at the answer I got when I did the first method, and if I look at the answer I did it with the second method, what do you notice about both answers?
They're the
They're
same.
the same.
Yeah, they're the same. So it doesn't matter which method you choose, like you choose the one that you think is easier. If you like converting to a z-value and then find the probability of that z-value, you could go ahead and do that. Or if you kind of just want to jump in and you get the answer straight away, you do it the second method. All right, so let's do B. So for B, it says about what proportion of his first serve would you expect to exceed 120? So let's go ahead and do this. We'll draw it out. 115. We'll say 120 is somewhere there. And if you look at it, it said exceed. Exceed means it should be bigger than 120 or faster than 120 miles per hour. So that means we shade the right-hand side. All right, so which method do you want to do? Do you want to convert it to z-value, which is the first method, or do you just want to kind of jump into the problem and you do the second method? So the first method or the second method?
Second.
All right, cool. Let's do the second method. So for the second method, sorry about that. We'll put mean, we'll put sigma, we'll put lower bound, and we'll put upper bound. So for this one, if we're doing the second method, we leave the mean and standard deviation as what was given to us. So the mean and standard deviation was given to us as 115 and 6 miles per hour. So if you look at my lower bound, what's my lower bound?
120?
Yeah, 120, perfect. If you look at the upper bound, what's the upper bound?
Positive infinity.
Positive infinity. Good. All right. So let's go to class calc and let's do the answer. All right, so if I do this in class cal, we'll say stats, we'll say distribution, we'll say normal distribution. You say the mean is 115. We say standard deviation is equal to 6. And you want to make sure they say this is a CDF. We put that the lower bound is 120 and the upper bound is infinity. If you look at the drawing it's giving me, well, you want to be careful. Let me deselect this one. Cool. So if you look at the drawing that gave me, it kind of matches up to the drawing that we drew. And it's telling us that this has a 20% chance of occurring. So we'll say probability that X is greater than 120. Well, that just equal to 0.2023. And that'll be it for that part B. Any question for the part B? All right. So up next, what I want you to do, I want you to practice on part C. So I want you to practice on part C. I'll do a poll, and that way you just enter your answer into the poll. So we'll say A, B, C, All right, so those are your 4 options. So let me do a poll. And once you think you got the answer, just select the correct answer. So far we got 3 people. Cool, 5 people. All right, I think that's as many of you that I'm gonna get. So let's share. Sweet. So if you look on this, 71% of you said C, 7% of you said B, and 21% of you said D. So don't know how to do it. So let's try to show them how to do it. So the correct answer should have been C because it is equal to roughly 20%. So let's go ahead and do this problem. So if you look at this one, you have 115 right here in the middle. But if you look at it, we want it to be between 100 and 110. So 100 and 110. So we'll say 100 and 110. Since it uses the word between, you shade in between the two values. Cool. So let's go ahead and do mu. Let's do sigma. Let's do lower bound. And let's do upper bound. So for this one, what will be my mu?
What was it?
What will be my mu?
115.
Perfect. So then sigma will be 6. What will be my lower bound for this case scenario?
100.
100.
Perfect. And what will be my upper bound?
110.
There you go. Good. All right. And like for a test, if you do use this method, make sure that you give me this so that way I at least know what you're doing. What was that? All right. So yeah, so in a test and a quiz, like at least give me this so that way I know how you're entering into class cal. All right, so let's go ahead and enter this into class cal. So let's go to class cal. All right, so I'm gonna just use this one again because we already have the mean and standard deviation of 115 and 6. So let's just change the lower bound. Lower bound should be 100. Upper bound should be 110. And if you look right there, you get 0.19611. But I just rounded it out to 0.20 because make it easier on you. All right, but that's it for the part C. Any question in regard to part C? All right, so let's do the last part, or sorry, we're gonna do D and then E. So for part D, it says the fastest 30% of the law first serve go at least what speed? Okay, so if you look at this one, they're not asking us to find the percentage. They're telling us like how fast the Rafael Nadal first serve has to be in order for it to be the fastest 30%. So let's go ahead and draw this out. So we still say 115 is right here. So we have two options. I can either say this is the fastest 30%, or I could say this is the fastest 30%. Here, let's say this is option A. Let's say this is option B. So tell me, which one do you think will be the fastest 30%? And just answer it in the poll. So do you think A will be the fastest 30%, or do you think B will be the fastest 30%? Whoa. I think we kind of slowed down. All right, so let's share. Share result. All right, so if you look at you, 13 of you said B, and if you look at only one of you said A. So the correct answer for this one, if we want the fastest 30%, it should have been B. Because remember, the fastest 30% mean it has to go faster than 115 miles per hour. If you look at A will technically be the slowest 30% of his serve. And if you look at B, since it's above the 115, it will be the fastest. So if we want the fastest, we want to draw like B. Oops, don't want to do that line. Whatever. All right. Everybody go with that? So what we have to do, we're gonna have to find what is this X value that goes here. So like you should already kind of have something that's saying like, okay, since I know X is to the right of 115, X should be a number bigger than 115. So let's go ahead and write out how we'll do it in class calc. So we're saying normal, distribution, and you're gonna put mean is 115. You're gonna put standard deviation is 6. But then we're gonna do inverse. Here, I forgot what it is. Inverse CDF, there we go. So we're gonna do inverse CDF. What do you think I should do inverse CDF of? Like, what should I put in between the parentheses?
0.3.
All right, 0.3. So let's go ahead and do inverse CDF of that. All right, so I'm gonna actually just clear this, get lost. So we'll go right here. I'm gonna add the inverse CDF. So we do inverse CDF, we'll say 0.30, that's what y'all told me. So if we do 0.30, we get X is equal to 111, and we'll say 0.9. You have to kind of keep it to one decimal place. So let's go back to my answer sheet or to my notes. All right, so look at that X value. Does that X value look right?
Nope.
No, because if you look at 111.9, 111.9 is over here. So what did we do wrong that caused us to get an answer that's so not correct?
Isn't the inverse CDF not supposed to be 0.30?
Well, what is it supposed to be?
0.70?
Only to the left.
Because remember, the inverse CDF always wants the probability to the left. So if you give it the probability to the right, it's gonna go like, okay, we're gonna think that this is the probability to the left. So what inverse CDF just gave me, it gave me the bottom 30%. So you always have to be careful with this. Always put the probability to the left. So what we have to do, we have to change this to 0.70. And we're gonna get a completely new answer. So do be careful with that because the calculator is only do what you tell it to do. So if you're telling it to do something wrong, well, it'll do it because it doesn't know better. So we change it to 0.70. All right, and now if you look at it, we get 100, oops, we get 118 point, what do you say, 0.1. So in order for it to be in the top 30% speed of serve, it has to be 118.1. And if you look at the 118.1, that looks more believable because it's greater now than 115. And that's it for D. Any question for D? Right. And we're gonna skip E because you don't have to know that. All right, so let's do this last problem, and that way you could get you in your activity groups. So for this one says, suppose that Clayton Kershaw of the Los Angeles Dodgers throw his fastball with a mean velocity of 94 miles per hour and a standard deviation 2 miles per hour, that the distribution of his fastball speed can be modeled by a normal distribution. So right here, the two important things he gave me, mean is 94, standard deviation is 2 miles per hour. So let's do A. So for A, so about what proportion of his fastball would travel at least 100 miles per hour? So let's draw this out. So we put 94 over here. If you look at it, it's 100 mile per hour. So if it says the word at least does it mean it has to be bigger than 100, or does that mean it has to be smaller than 100?
Bigger?
Yeah, bigger, good. All right, so let's figure out what are we gonna enter into class Cal. All right, so in class Cal, what we're gonna do, we're gonna enter the mean, the standard deviation, the lower bound, the upper bound. So the mean and the standard deviation, if you do not wanna find the z-score, you just leave it as 94 and 2 for the mean and standard deviation. So for the lower bound, what's the lowest value that gets shaded?
100?
There you go, 100. What's the highest value that gets shaded?
Positive infinity?
Perfect. All right. So let's go ahead and do this on class calc, and we're done with part A. All right, so we go to stats, we go to distribution, and let's do normal distribution. You put mean is 94. You put standard deviation is 2. And then lastly, you put CDF. Oops. So if you look at it for the lower bound we said was 100. For my upper bound was infinity. All right, so if you look at it, we get a probability of 0.0013. So I say probability that x is greater than 100 is equal to 0.0013. So if we get a probability of 0.0013 of him throwing at least 100 mile per hour, is it very likely that Kershaw will throw a fastball that's 100 mile per hour?
No?
Yeah, no, because if you look at it, it's less than 5%, so not very likely that he'll throw a fastball that fast. And that's it for part A. All right. So let's do part B. So for part B, it's about what proportion of his fastball would travel less than 90 miles per hour. So let's go ahead and draw this out. So he's still 94. And look at, since it said 90 miles per hour, 90, it should be to the left of 94 because 90 is smaller than 94. If you look at it, since it says less than, which side of the 90 should I shade? Should I shade to the left of 90 or to the right of 90?
The left?
There you go, to the left. All right, so let's go ahead and do this again. So if you look at the mean and if you look at the standard deviation, that's gonna remain the same. The only thing that's gonna change is my lower bound, my upper bound. So for my lower bound, what should be my lower bound?
90.
Negative infinity?
Yeah, so for the lower bound, it should be negative infinity. If you remember the lower bound, what's the lowest number that gets shaded? If there's no cutoff, you say negative infinity. So for this one, it should be negative infinity. What about for my upper bound?
90?
Perfect. So let's go ahead and do this on class Cal. All right, so in class Cal, we're gonna put negative infinity. Oops, no, gotta hold it. So negative infinity, and for the upper bound, you put 90. And we get the probability that x is smaller than 90 is equal to 0.0228. That's it. So it's very unlikely for Kershaw to also throw a fastball that's below 90 miles per hour. So essentially, that might be considered his changeup or something. All right, but that's it for part B. Any question for part B?
No.
I just have a question kind of in general.
Yeah, what's up?
Every time you get your answer, like right there, it says on class calc, it always says that it's a negative. We just disregard the negative?
You're saying that on mine show negative?
Yeah, on class calc, when you show us the answer, like right now, when you were sharing your screen.
No, it's not a negative, it's an equal sign. Can I see? Okay, you're talking about this one over here?
Okay, yeah. Yeah, never
Yeah,
mind.
no, it's an equal sign, not a negative. Sorry about that. So let's go ahead and back. All right, so let's do C. So for C, it says about what proportion of his fastball would travel between 93 and 95 miles per the hour. All right, so this one you might get a high probability. No, well, we should get a high probability. So if you look at this one, it says between 93 and 95 miles per the hour. So here you go, 93. Open 93, and here you go, 95. Like the reason you should kind of know this should give you a high probability because if you look at both of those numbers are pretty close to the mean. And it says between, so you want to say in between. All right. So let's go ahead and do this. So for this one, what will be my lower bound?
93.
93, perfect. And then for my upper bound, what will be my upper bound?
95.
And 95. All right, so let's go ahead and do that. So we'll go back to class calc and where you're gonna adjust the lower bound, the upper bound, because if you look at the normal distribution, you could leave it as is. All we have to do is just adjust the lower bound, which is 93, and adjust the upper bound, which is 95. All right, so you get 0.3829. So we get the answer to be 0.3829. And that'll be it for the part C. Any question for part C?
No.
All right, so let's do the last part. So let's do part D. All right, so for part D, it says, what is the 30th percentile or Kershaw distribution of fastball velocity? So right here is asking for the 30th percentile. So you kind of know anytime that you use the word percentile, they're always talking about the bottom. So if it doesn't mention any, if it just mentions percentile, just know it want the bottom percentile. So for this one, we shall automatically know that we want this percentile. So anytime they say a percentage and then they say percentile, they're just telling you they want the bottom percentage of that, or they want the X value that corresponds to that bottom percentage. All right. Everybody so far go with it?
Yeah.
All right. So then we'll put normal distribution. You put mean, which is 94. You put standard deviation, which is 2. And then for this one, since we want to get what's his speed velocity for 30 percentile, you want to do inverse norm. So we'll do inverse CDF. And for this one, what's my area to the left?
30?
So for this one, you actually do want to put 0.30. For this one, you wouldn't put 0.70 because we want the bottom 30 percentile. So let's go ahead and do this next step. Let's do class calc. All right, so in class calc here, we'll just start a new one. So we'll say stats, distribution. We'll do a normal distribution. So we're doing it with mean of 94. We're doing standard deviation of 2. And then you want to go ahead and do inverse. So we'll say distribution, we'll say inverse CDF, and this time you put 0.30. All right, and if you look at it, you get roughly 92.95. So yeah, X is 92.95. So if we want to clock Kershaw like lowest 90 percentile of his fastball, pretty much the lowest 90 percentile of his fastball will be anywhere between 92.95 mile per hour or something slower than that. And that's it for part D, and that's it for the lesson plan. Any question in regards to the last problem? All right, so that's pretty much it for today's lecture. There's not that much time to do a breakout room. So what I'm gonna go ahead and do, I'm gonna just end today's meeting and I'm gonna just start my office hour. So if you do have any question about today's lecture, you can just go on the office hour and that way you can ask me during there and yeah. But any questions before I close this meeting down? All right, so just a reminder, you do have a quiz today, and the quiz today on what we learned yesterday. So the quiz should open up today at 12 p.m. and get a close at 11:59 p.m. today. So you do kind of want to go ahead and do that as soon as possible. I'm also going to grade the quizzes right now. So your quiz score should be popping up by the end of today. All right, guys, so that's it for today. Have a good day, and I'll see everybody tomorrow.